Hello everyone. In today's lecture, we are going to discuss about the reflection of sound. Now, as we have already studied in case of light, that is the light rays they get reflected from any interface or surface, plane surface, rough surface, isn't it? Any kind of surface or any kind of obstacles. So similarly, the sound wave also gets reflected if they being incident on any kind of surfaces or any kind of objects in their path of propagation, right? So let's see one picture over here, then I hope you will get the better understanding. So now as you can see, the sound is transmitted, okay, or propagated from the speaker, we call it as a sender, okay. Now that sender or the source of the sound propagates or transmits the sound in the air. Now the sound travels. After traveling, if there is an object on its way, okay, which will act as a hindrance, okay. Now from that object it gets reflected back. As you can see, the reflected wave is shown in the form of dotted curves over there, as I hope you got that right. Now there is a distance sensor also along with the sender or the speaker, okay, that is the sender of the signal. Along with the sender of the signal, there is a distance sensor also which senses the reflected sound, okay. So now when it senses, it can be proved that yes, the sound can be reflected back into the same medium, same as the light do, same as the light rays do, okay. Now so reflection of sound or reflected wave, reflected sound wave is also called as echo. What is that? Echo. Now I hope you have heard about the word echo, which we are going to study in the next coming lectures in detail, but let me tell you what is echo. That is the reflected sound wave, okay, after bouncing back or getting reflected from any hindrance or from any object is nothing but echo. So sound waves also get reflected as light waves do. Bouncing back of sound wave from any surface of solid or liquid is called reflection of sound. I hope you got that right. Now let's see whether the sound wave follow the same rules of reflection as the light waves do or not. Let's see. Now as you can see, so there are two tubes over there, as you can see, and at the opening of one tube there is a stopwatch placed, and the stopwatch makes noise, isn't it? Makes noise or makes some sound. So that sound is traveling and there is a plywood kept, okay, and from the other open end the sound gets incident on the plywood. Now as you can see, there is a normal line drawn, right, normal line drawn on the, or you can say there is a soft board kept on the normal line, and after getting incident, the reflected sound wave is making same angle, that is angle of reflection as of angle of incidence, because in light, as we have already seen, that is angle of incidence is equals to angle of reflection, isn't it? Angle of reflection. The same way, the incident ray or incident sound wave over here making an angle I with the normal is incident on the plywood, and after reflection from the plywood the reflected sound makes an angle R with the normal line or soft board, and that is being received by the human ear, as you can see. So over here the reflected sound and the incident sound both will make same angle, that is angle of incident equals to angle of reflection, same as the light waves. I hope you got that right. So reflection of sound follows the same law as the reflection of light. When sound is reflected, the directions in which the sound is incident and the reflected make equal angles with the normal to the reflecting surfaces, and all the three are in the same plane, that is the incident ray, okay, incident wave, reflected wave, okay, reflected wave and the normal all lie in the same plane, that is according to our laws of reflection, that is angle of incidence equals to angle of reflection, and incident ray or incident wave, reflected wave and normal all will lie on the same plane or in the same plane. Now as we know that sound wave gets reflected or gets bounced back after reflection or after hitting any surface, right? So, but whenever a source of sound is at far distance, okay, the sound travels to us, okay, travels to us or reaches us after multiple reflections. So let us see, multiple reflections of sound. Sound can get reflected many times before reaching to us. The multiple reflections of sound has a number of uses and consequences. So now, as we have already said, that the sound gets reflected many times before reaching to us, right? Because there would be number of objects, number of surfaces present between us and the source of the sound. Let's see what are the multiple uses of reflections of sound or multiple reflections of sound. So applications of reflections of sound: stethoscope, soundboard, megaphone, loudspeakers. Now stethoscope, the sound gets reflected. I hope you know what is stethoscope, right? So stethoscope, whenever this particular the object which is fixed at the other end of the pipe, okay, you can see that that object, when it is touching the patient or any heart of the patient, I mean the chest, okay, so the heartbeat, the sound of the heartbeat travels through. Now if I show you the inner structure of the pipe, okay, so the sound wave get reflected like this. It reflects, again comes back like this, again reflects, again comes back like this. So actually I am drawing in the form of wave. If I show you in terms of ray, actually it doesn't transmit or doesn't move in terms of ray, but if I show you, it moves like this, okay. This is the path, this is the path. I hope that is clear, right? So this way the sound wave gets reflected multiple times before reaching our ears when we put on the stethoscope, right? I hope that is clear to you. And soundboard is nothing but which is used in your auditorium or hall to make the sound, okay, get transmitted into a large space, you can say, okay. It's the design of the soundboard is somewhat like this. This would be the source of this sound, which will be transmitting signals, okay, or transmitting sound waves, and after reflection they become like this. See, as you can see over here, so these are the sound waves. From a small source of a sound, it can be reflected, okay, and sent to the large space in a hall or auditorium. That is the application of soundboard, right? And similarly, megaphone and loudspeakers, of course, as you can see. So to make the sound to reach in a large space, okay, or to make the sound to reach large number of gathering, okay, we use this type of speakers or megaphones. I hope that is clear to you. So these are the applications of reflection of sound. From a small source, we can make the sound wave go on having multiple reflection in order to reach a specified number of gathering or people, or you can say space, right? So that was all about the reflection of sound and multiple reflections of sound and their applications. I hope that is clear to you. Thank you.